Jackie is the Director of Policy Analysis at the National Center on Education and Economy. And she's going to share findings from a review of how math is taught differently in systems across the globe with strong performance in mathematics. The review looks at differences in both content of mathematics and instruction and how educational systems are structured that impact how math is taught. The NCEE is a nonprofit-based organization in Washington, D.C. that has focused for more than 30 years on identifying insights from global benchmarking to inform national, state, and district policy and practice in the United States.
Thank you so much for the invitation to be here this morning. I think Nancy summed up a little bit of the introduction, but I'll just tell you a little bit about who I am. So I work at an organization, as Nancy said, called the National Center on Education and the Economy. And we're in DC, have been around for many years, and we're a nonprofit, and we work with states and districts across the country on their education system and also work on national policy. And we come at this from two key perspectives, I think. One is really looking at the connection between the education system and economic strategies in the country and the connection between those two. And also, as Nancy explained, we come at this looking at a global perspective, looking broadly across the world at strong education systems and seeing what we can learn from them to inform policy in the US, and really looking at systems that are strong and what's common across those systems, despite the cultural and historical differences in many systems, and trying to sort of expand the lens. And in the US, a lot of times we really only look perhaps at other states to see what we can learn, and trying to sort of step back and look more globally to see what we can learn, not necessarily to copy other systems, but to inform our work in the US. And along these lines, NCE has created a new brief series, which is one of them that we'll talk about today, which we're calling the Thinking Differently series, and really focusing on different aspects of policy and system design in different in systems around the world, and just raising some observations about what seems strikingly different that's worth considering, sharing a lot of examples of how we see this playing out, and then sort of asking questions about what the implications may be for U.S. policy. And I probably don't have to explain to this audience too much about why math is one of the topics. Oh, and I didn't mention the first brief was about math, which is what I'll talk about today. But since then, we've also put together some briefs, which I'll share with this group in case you're interested, looking at global education systems from the perspective of how time is used differently. And we've done that in two parts, looking at time in elementary and middle schools. And then we're about to release another brief looking at high schools. And I think sort of the high school design and the pathways in high school has a lot of implications for mathematics, which I'm suspecting a lot of folks here have thought a lot about math pathways in high school. And then we're also working on one that looks at staffing and how that's different. But back to the math one. And again, this is something I probably don't have to explain too much to the group here. But as you all know, we've had longstanding concerns about the performance of students in mathematics in the U.S. And math and STEM areas are just becoming increasingly important for students and for the economy. And in math, there's been sort of an increasing consensus on some strategies in literacy and in reading, but in math, at least to us, it doesn't seem like there's a clear path forward. So, which makes it even more of a reason to look more globally and see what other countries are doing. And as most of you know, the U.S. lags far behind global leaders in mathematics, and that's been sort of a long-standing concern, and certainly in the latest round of various international assessments as well. And in the brief that we did, we looked at math in a couple of different sort of focus areas. We looked at the content, curriculum instruction, how math is personalized, how instructional time is used, and some issues around how teachers are prepared to teach mathematics. These are sort of a set of, as Nancy, I think, mentioned in the introduction, sort of looking at the math curriculum specifically, but also stepping back a bit to look at how the system is organized that impacts how math is taught, which is really important to think about when we're looking outside the US. And a couple of caveats before I start sharing an overview of some of what's in the brief. And I know Nancy and Rod, I think, shared the brief with a lot of you, so some of this might be familiar. But the brief itself is not an exhaustive examination of mathematics in other countries. It's really a first look and looking at some high-level features and characteristics of mathematics instruction in other countries that are raising some things that might be worth looking into in more detail. The systems we're looking at are not a one size fits all. It's not like there's one formula out there in high performing systems. They're different, and it's really interesting in a lot of ways to look at what's both in common across some of the systems that we look like, but also what's different, and with the idea that there's different ways of organizing instruction and organizing mathematics that's successful with students as well. And just one other note that a lot of the stuff we see, we certainly have examples of in the United States. You have examples in the United States of almost everything. But the thing that seems distinctly different to us sometimes is the fact that some of these policies and practices are done systematically in other countries. And having done a lot of the research that NCE's done over the years, visiting other countries, one of the things that always strikes me, it's sort of interesting. You hear people in other countries often telling you that the idea for a particular initiative or program was based on a visit they did to the US, or this is based on a school we saw in North Carolina or a practice we saw in Ohio. And then they've gone back to their country and they figure out ways of implementing it much more systematically than we often do in the US. But the US often has these sort of peaks of innovation that other countries around the world pick up on. So anyway, I'm going to do a bit of an overview of the content in the brief, but I'll pause after each section and see if there's questions and and if there's reflections or things that we want to talk about, because I certainly don't want to just sit and talk for a half hour at you, and would love to have more of a conversation about it. Looking at the first area, some of the big takeaways for us were around the idea that when you look at math curriculum, and we were took an overall look at curriculum in a number of different countries, one of the things that was interesting to us is that many of these countries have processes for updating and reviewing their curriculum very regularly. One interesting example was in Korea, where they do partial and full updates on a regular cycle of every 4 years. They do a review, and every few years after that, they do a comprehensive review. And doing that, they commission research to look at global trends. They look at workplace trends. They look at countries around the world and how their curriculum is changing. They evaluate how the curriculum was implemented in schools across the country. They have processes for getting input from teachers and students. And it's sort of an interesting process. There are certainly in the states, states do update their curriculum, and there are a couple of states that do it on a very regular basis. But it's interesting how systematic and how broad the updates often are in many other countries. In terms of the updates that have been happening more recently, I think some of the things that we saw will resonate with you as things that we see happening in the US too. There's been a focus on paring down content in math. Once again, I know that was sort of behind some of the thinking of even the Common Core standards back how many years ago now, of thinking about trying to pare down the US curriculum. But these systems are trying to pare down once again. There's a big focus, as wouldn't surprise you, on adding more data analysis and modeling and statistics to the curriculum. and a real focus on trying to align what happens in math curriculum with changes in the workplace, and really make those kinds of connections. The other thing, again, was probably not a surprise to this group, but from our vantage point, we see more consistent focus on statistics and data analysis. A lot of states have moved to in their more recent revisions of adding statistics and data analysis into the elementary curriculum, but you see internationally that's a feature in general of early grades through the upper grades in the curriculum, that it's sort of a strand throughout. And again, something that many of you may be familiar with, but in the U.S. Structure for mathematics beyond middle school of having sort of the algebra, geometry, algebra 2, the sort of sequence is not what you find in many countries across the globe. They more typically have integrated mathematics through ninth or 10th grade whenever their general common curriculum ends. And through that integrated mathematics, statistics continues to be a strand. And then the other thing that sort of jumped out at us is a number of countries, not all countries, but a number of countries really explicitly pull out sort of almost as a strand of mathematics, calculations and computational fluency, and in different ways. Some of them do it, in a different way. They organize it at elementary and middle school, but it goes throughout. And the sort of thinking of this when we've looked at what's written about it in the countries is really a real focus on what skills are needed at each level to move on to the next level of mathematics. So it's a sort of a narrow specified set of skills to move on to the next level. And again, we see some of this in some of the updates in U.S. states of their math standards of adding a more focus on that. Anyway, I'll pause for a minute, and not sure if there's questions about any of that before I move on to the next section, or any sort of observations or things that you want to talk about what's going on in Ohio in terms of updating the curriculum, or if there's, if what you hear about what's happening globally is reflected in some of the conversations in terms of thinking about math content in Ohio.
I'd like to ask you, this is Peggy Costin. I'd like to ask you about the impact that you believe is there because these are national curricula, and we don't have a national curriculum.
Yeah. I think I think that's a huge piece of thinking about what goes on in these systems. That's sort of something I was going to bring up a little bit later in the discussion, but I think that's a big piece of alignment across schools. One of the things that I'll talk about a little bit later is the fact that what they call national curriculum really has a lot more in it than what we often have at the state level, which is a set of standards, which provides a much broader set of guidance for schools and teachers around teaching of different subject areas. I think that's clearly a huge thing that is different in many other countries.
So, Jackie, you talked about in Korea, they had a set time where they would review the curriculum every 4 years. Do they do everything all at once, or is there a rotation?
They do the full curriculum, but they have a different process for what they call partial updates, and another that's a full review of the curriculum. So when they do partial updates, sometimes they focus in on different pieces of it or different themes that they're concerned about. But there's a process for reviewing the full piece, the full curriculum at regular interviews as well.
And from the beginning of the school system to the end, so like here we would have K through 16. I know different nations have different ways of structuring, but it's all levels.
Well, they're looking at K through 12 in this part of it, not the post 12th grade curriculum. That's part of this process, at least that we looked at.
And have you found a focus on conceptual understanding?
Yes, that's definitely part, and that's part of the rationale for paring down the content in the curriculum has been paring it down to key concepts and skills that students most need, plus adapting the curriculum for a changing globe, a changing workplace, the advance of technology, data, things like that. So those seem to be the key trends that we saw.
This is Peggy again, and I don't want to get ahead in your presentation, so put me off if you need to. A lot of what you've said is similar to things I said 40 years ago.
Yes.
When we looked at this, but when you talk about how we lag in performance, it used to be that our top students were roughly equivalent. Is that not the case anymore?
I don't know if I can speak to that specifically. I know, I know sort of how our top students compare to top students in other countries on some of the international assessments. And I think that is less the case. I think a lot of these countries have a larger percent of their students scoring at higher levels on national assessments than we do.
Okay.
Yeah.
And I think Chris has a question.
Sure.
Yeah. So two comments. One is that there's a group called Data Science for Everyone that's headquartered at the University of Chicago, and they are trying to get some momentum for K-12 data science and data literacy standards, which are already there in a lot of ways,
Right.
but they just want to continue to highlight that. Because of how much the field of data science has grown. So I got to sit on one of those committees at one point. And in Ohio, we're very proud to have the data science pathway. We're the first state to do a full statewide data science pilot. So thumbs up for Ohio.
Yep.
The other comment that I have is that computer science has been growing like crazy. And I do not understand why there isn't more discussions about putting binary numbers into elementary and middle school math. It's like everybody in the computer science silo is just in this echo chamber, and the math people are over in this echo chamber, and no one's talking to each other to even suggest such a thing.
Right.
That's my impression.
I don't know the curriculum at that level of detail, but I would wonder, and I'd be happy to actually share it with you directly, if you looking at some of the curricula, particularly Korea and Estonia, which have long been focused on technology and integrating that into the math curriculum, whether their curriculum reflects something more like that than we do in the US.
Yeah, I'd love to know.
Yeah, that'd be sort of an interesting question. Maybe I will move on to the, sorry.
It's just going to jump in. So Chris, a lot of our STEM and computer science teachers at the elementary school are covering a little bit of binary. It's not regular and it's not necessarily everybody, but we're trying to get some more computer science across the curriculum, starting K at the kindergarten level.
Yeah. Just one comment on what you just said. One of the things that we've noticed, which I don't think is actually mentioned in the report, is a number of these systems have had for a long time a computer science curriculum, like alongside their curriculum, and there's been a trend to integrate it into the subject areas and move away from having a standalone curriculum, which sounds like is a bit of what may be happening in Ohio as well.
Yeah, if we're serious about computer science for all, it needs to be in the math standards. We need to not have these like silent,
right,
deep dumps and things. And the branch for all, please.
Okay, I'm going to move on to the next section, which gets a little bit to some of the national curriculum issues that you were raising before. But one of the things that we've also see, and I think this probably resonates with you with the things that you've talked about that have long been observed about other systems, is that the curriculum like instructional materials and instruction are highly aligned, and there's reasons behind that. One is what I was mentioning a little bit before, is that curriculum, the word curriculum means something a little bit different in a lot of these systems. In the US, as we said, a lot of times the state standards are just a set of standards and some, supporting materials. But when you look at national curriculum in a number of countries, it doesn't mean curriculum the way we think about curriculum here of like a textbook, but it's a curriculum that lays out standards. It lays out assessment criteria for those standards, guidance on how to organize teaching, progressions. Many of them have suggestions on time allocations of subjects and how they're taught at different grade levels. And then there's aligned materials that are often either produced by the ministry or Department of Education or the government, or materials that are approved. If they're developed by private publishers or by teachers, there's approval processes, and part of that is making sure that they are aligned to the specifications, which are much broader than a set of standards for each subject in different countries. So it's sort of a much more sort of tightly connected approach to each subject area, to mathematics and other subject areas. And then there tends to be a lot more alignment in what goes on, at least in the approach to subjects in teaching, because a lot of that is specified at a sort of national or jurisdictional level. Which is really sort of interesting to see and think about in terms of what our conversations in the U.S. The other thing that we see in many of the countries, not all countries, is the idea of math, the math being modularized for teachers and for students. One that we looked at in particular, which was interesting, is Hong Kong, that really sort of divides the math into a small set of units for each grade level, with really detailed explanatory notes in terms of how it fits in the sequence of teaching, key points that are important, areas that students may misunderstand, and ways to go deeper with the content that are, again, voluntary materials, but since they're used very broadly and end up being really useful resources for teachers. Another sort of theme of stuff that we noticed, that I know has been sort of a conversation in the US for years as well, but ways that math is integrated across the curriculum in really intentional ways. Almost all of the math curricula that we looked at has really specific guidance on using and how mathematics and mathematical concepts can be used in different subject areas, with detailed examples. One of the things that was really interesting I think it was Korea, in their latest revision of their mathematics curricula, is they tried to align by grade level the mathematics and science and some of the other subject areas, so that they could give specific guidance of at a second grade level. These are some of the concepts that we're teaching in math. These are some of the concepts that we're teaching in science. And here's some ways to apply the math to the science that's going on. The other, in addition to the sort of really specific guidance, not in a general way, it's a good thing to integrate, but here's a whole bunch of different examples and approaches that you would take in different ways in different subjects. Is that many of the systems we've looked at have required themes or interdisciplinary types of projects that are required for schools to organize learning around. And it's another sort of opportunity to bring math into outside of the math classroom into a thematic kind of course. In I think it's Finland, they have themes around things like sustainability, civics, career areas, and the schools organize, they do this in different ways. Some of them do one big project each year or one each semester, and they sort of bring different subject areas together around a theme or a project, and you see a lot of math in those projects as well. So it's another sort of opportunity to use and apply math. And then the other thing that we looked at is the way that technology is being used, and this is sort of such a big conversation these days. One sort of framing comment around that is that a lot of the systems that we've looked at pre-pandemic were in a position that was much more, they had put a lot more thought into using technology and creating national platforms for technology before the pandemic. One that sort of stands out was Singapore, which had the SARS pandemic not pandemic, the SARS in 2013. And they were, and at that point, they actually had to close down schools for periods of time. So they, at that point, created a national learning platform that they spent several years adding curriculum material and digital tools to and trying out in schools. And so, when the pandemic, I mean, nobody was prepared for COVID, but it was interesting to see that a number of these systems had really invested for many years in sort of in digital learning and using that in classrooms, and which sort of went into the pandemic at a different starting place than a lot of schools in the U.S. And and since then have expanded that. Singapore, for example, now requires that all schools have digital learning days every 2 weeks. They sort of have regularized this into their systems and are really thinking about sort of ways of having students learn independently in scaffolded ways throughout school. But it's interesting to see the way that technology is used, particularly in math. There's a lot, and not to keep using the Singapore example, but it's the one they had jotted down. They've been using adaptive technologies in mathematics for a number of years. It's interesting how they use it. It's not just sort of a practice tool, but they are working with teachers to sort of use it as a way to gauge where a class is at the beginning of class, to sort of adapt the class lesson each day. And they're doing this sort of in a very sort of scaffolded way of thinking of they started a pilot in mathematics in 1 or 2 grades in 1 or 2 curriculum areas, and really sort of have experimented with ways that they can use that. But you also see technology embedded into the use of using technology as a learning tool embedded into the curriculum. Estonia is a really good example of that, because they're a country that's been really focused on creating a digital society and having that be part of using the schools as a way to enable that. So for many years, they've had, you can see in their math curriculum that they look at, you teach patterns using technology, how to use it, and using tools to teach specific kinds of skills using technology and the ways that you can do that. They also have, which is interesting, a set of modules, and this sort of goes back to the idea of using math across the curriculum. They've developed a set of modules for teachers in different subject areas to use to try to apply data, prototyping, AI to different kinds of subjects, and sort of have different focus areas for different age levels of that, and have they actually have technologists. They've created a position called education technologists, who are in schools who have subject specialization. So they have a math technologist who works with teachers to figure out how to use technology to enhance their teaching. They have ones who work with literacy to enhance literacy. So it's an interesting model that they do. But again, I will pause again and see if there's questions or any kind of discussion you want to have about that broad set of issues.
This is Kim.
Yep.
I'd like to pose a question. Yeah. Thank you so
Sure.
much, Jackie. This is fascinating. I'm curious, and I'm articulating this as I'm speaking. So, I mean, I'm thinking as I'm speaking. So forgive if this doesn't come out quite in a sensible way. But so I'm thinking about these very broad, inclusive, humanizing ways of thinking about mathematics, and connecting more directly to the natural world and to the humanities, and seeing mathematics in all of those areas and within us as human beings, and sort of locating mathematics and human beings, and not only or in a sort of prioritizing way in digital technologies and kind of the traditional STEM fields. And I'm just thinking about, what do you see in other countries that, if anything, that relates to that idea? Like sort of coming back to, how do we connect mathematics to the earth, the natural world, to people?
Yeah. I'd have to think about that a little. I mean, the immediate thing that jumps to mind a bit is what I just mentioned in some of the countries that we've looked at who have identified these sort of themes and sort of interdisciplinary priorities that they want to make sure that students are, to be an educated person, you really need to understand civics and sustainability and, those kinds of themes and bringing the different content areas into those kinds of things. A lot of the Scandinavian countries in particular are very focused on the natural world and sustainability, and do some really interesting kinds of projects around those kinds of things. The kinds of stuff that you would imagine. So it really sort of spans the gamut. I mean, there's a real, focus on increasingly on career areas and things like that as well, but also these broader themes of, sort of seeing school as a place that you build the national priorities around things about well-being and about the outdoor world and globalization, and a lot of those kinds of themes are increasingly embedded in an array of subject areas, and it's interesting the way that it's sort of done, not just as a goal, but as an explicit requirement that schools organize curriculum around these areas, in addition to the work they do. We did, for one of the other Thinking Differently briefs that we did about time, we've also we've now done some case studies of sort of how this comes together in different schools. And it's interesting. There was a school that we talked to in Estonia that it's kind of a model school, so a lot of other schools are looking at it, but they've done something like this where every semester they pause and they have an interdisciplinary project around things like civics, and they're sort of creating curriculum around those kinds of things. So you really see it happening in a systemic way in some of the other countries. Yeah.
Thank you so much.
Sure. Move on. Another sort of lens on this work that we looked at is the idea of how math is personalized, adapted for different students depending on their needs and interests. And some of these things are more stepping back and thinking about how the structure of the schools are organized that impacts how math is taught. But one of the things that's just sort of an interesting, as we brought up before about the idea that there's a national curriculum. One of the things that's really striking about most of those national curriculum is that they organize learning and standards by stages rather than grades, and in grade bands. Which, typically something like, first through third grade or fourth through sixth grade, seventh through ninth grade. And you see how that builds in more room to pace learning in different ways, depending on who the students are and how a teacher wants to organize instruction. Quite often the external assessments are pitched to the stages rather than sort of the grade by grade kind of teaching assessments that we have in the US. I mean, and I'm sure many of you know this, but the testing at every grade level in math and reading is something that is fairly uniquely American. Most other countries have external exams at sort of key stages in education, which just orients the school in a different way. It's interesting to see. I mean, one of the things that sort of jumped out at us when we were looking at this was Denmark, and I think it's in the brief. In Denmark, they have something called, and this is specifically in mathematics, they have something called attention points. So at each stage in learning, they I think have something like grades 1 through 3. They pull out like the really core necessary skills or concepts that students really need to know to be able to move on to the next stage of mathematics and be successful. So it's not the entire set of work, it's the stuff that teachers really need to pay attention to and worry about students being prepared to move on without understanding that. And they've sort of laid that out by stages, but it sort of speaks to the thinking behind some of those approaches. The other thing is and again, what I think I mentioned earlier, that some of the national curriculum really lay out time allocations by subject, and which is part of the guidance of how schools operate. And what's interesting to see is both the idea that there's time allocations by subject, but there's also significant amounts and increasing amounts of flexibility time built into the schedules as well. I think one of the sort of examples that jumped out at us is in Hong Kong in primary school, 25% of the curriculum is flex time, and that is intended to allow teachers to organize, support for students who need it, acceleration for students who are interested, sort of ways of deepening the curriculum, applying the curriculum to different subject areas, and sort of space in the curriculum. There's also, you sort of see not just sort of space within a school year, but something that's interesting, and that's a bit of a theme in some of the work that we just did in the other briefs around how time is used. A number of systems have organized transition years, like they're extra years of learning that can be built into the school year, generally around 9th or 10th grade before students go into high school and make choices of different pathways in high school. And what's also been interesting is that some of these traditionally have been around giving students who need extra time to work on skills, and to sort of catch up on on skills to be prepared for programs that they might go to in high school. Looking at the sort of idea of a transition year more broadly, Ireland has something they call their transition year, and it's really an exploration year for students at 10th grade. It's voluntary, but I think about 70 or 80% of students and schools do this. And students get to try internships. They can work on skills if they want, try courses that they hadn't thought about trying that might be ones that they would focus on in high school. It's kind of like a gap year, but at 10th grade, not after high school, which is sort of an interesting concept. And then also ways that systems have organized to allow students to learn at their own pace. There's sort of use of technology to do this. There's policies in place to create individualized learning programs for students, which is interesting. Sort of at a national level, work. I think it was Finland of promoting the idea of multi-grade classrooms, so that students can move in a competency based way. And then one big theme of what we look at, which again is, I think, maybe familiar to a lot of folks here on the phone, is the idea of secondary math varying by student pathway. Again, as I mentioned before, one of the projects that we've worked on more recently is not looking at that only just in terms of mathematics, but really sort of looking at how high school is structured in different ways. And what's really interesting in there is, we have a lot of discussions around pathways in high school in the US, but when you look at some of the systems that we've looked at, pathways in secondary school is really sort of a different order, I would say. And there's a way in which high school resembles a lot more like our post-secondary system than our high school system. So the pathways are not electives within a standard 4-year program where there's a common set of requirements and a common diploma at the end, but it's really an earlier choice point of students being able to choose sort of what they want to focus on learning, where they want to focus, workplace learning, school learning, how long the programs vary in length. And as part of that, the mathematics varies as well. And there's a phrase that somebody used that to me just resonates in sort of a way to think about it, that in a lot of ways the mathematics and other parts of it are sort of learning things just in time for what students are aiming for, rather than just in case, which is a way that in the US we have sort of general education that goes on a lot longer than it does in many other countries. And in those countries, it sort of raises issues about how we think about equity. But in those countries, the thing that's interesting to think about is that the choices are earlier and the math might be earlier, but there's a lot of ways in which students can change direction, add on, they can take up an apprenticeship, and learn a certain kind of mathematics, but then make a decision that they want to go to university and add an extra year to fulfill university requirements and learn different math at that point that they need for whatever their changed goal is. So it's sort of just interesting to think about it in a sort of how the system works, and then underneath that, what the curriculum looks like. And again, I will pause for a moment if there's discussion or questions about how we sort of personalize the mathematics for students here, and maybe what's going on in Ohio or any of your contexts.
One of the things that I have to say, I like the word personalization, and we use differentiation, and a lot of people get turned off by that word. So personalization, I think, could mean the same thing, but in a more positive way.
Jackie?
Yep.
In Ohio here, we've been doing the coalition has been doing a study of the 600 or so public school districts, and looking at the top 100 and the bottom performing 100. And there's such a difference in the socioeconomic status of these school districts, or the socioeconomic status of the parents. And then you see many of the city school districts. We have cases where the attendance is only 50%. And so as you've been talking, what I see is something that will work well with our well-performing schools. But the problem is at the lower end, where we really need to make a big difference. We don't have parents that are engaged. They're not doing all the things that the top 100 districts are looking at. When we did our survey, we were looking at we saw two studies that laid out 9 characteristics of top performing schools. And we found that basically that's true, that the good performing schools kind of do this, not all the same, to the same level, but they do it. And we don't find that, and we don't know how. At least we haven't been able to think, how do we take and change things in a way that allow the tail of the distribution of performance to be brought up. There's just so many cultural things involved. When you look at these other districts, I've heard said in the past that we're comparing ourselves against smaller countries where they're maybe more homogeneous. I don't know that that's true, but certainly in the United States, if you really look at things carefully, we're culturally, we're socially, economically, and inhomogeneous. And I wondered if there's anything you could say when you've looked at these other school systems or countries, have these kind of things come into question and play?
Yeah, I mean, there's a number of ways to approach that question. One is a number of the systems we look at are, in some ways they are smaller than the US. I mean, the US is huge and sort of uniquely structured in the world with 50 states, but many of them are similar in size to our states. And that's sort of the comparison that we often think about. And I think that there's also, the US has its own unique cultural history and ideas and sort of heterogeneous, population, diversity of population. But many of the systems that we look at are quite diverse in different ways. They might have language minority cultures. They have certainly socioeconomic diversity. Many of them in, dramatic ways as well. So the racial issues aren't always the same, but I think part of the way that we've approached this work over many years is trying to look at what's in common across systems that perform well despite some of the cultural and historical differences, and look at equity within the context of equity in those countries. There's sort of setting aside sort of the focus on mathematics, some of the other stuff that we see in some of these countries that seem to have better results for a wider distribution of students in the country, students are coming to school better prepared. There's more focus on universal early childhood education, support for more focus. There's a foundation of support in the society that helps make sure that students are either both prepared coming to school and also supported while they are in school. That, is different than what happens in the US in many situations, but not all. I mean, we have significant supports for students too. One of the other sort of key things that we see that I think really speaks to some of this is the idea that many of these systems are much better aligned and coherent in their policies. And the US is sort of uniquely has, crazy governance of a lot of different aspects, not just of the schools, but outside of schools as well, that, are probably underlying some of the struggles that you talk about, where, for example, in many of these countries, there's health centers located in schools. There's a much more comprehensive set of sort of local services and supports for families and children and things like that. So I don't want to sort of set aside that piece of it as well, but I think there's also, looking at what goes on in various countries, there's also a lot that the schools can do, aside from the foundation of support, that you really see kids who are coming in with disadvantaged backgrounds performing at much higher levels than many, kids on average do in the US. And that may speak to some of the things around teacher preparation, around teaching conditions, around perhaps, some of the conversations we've had around absenteeism also have sort of pointed to the ideas about, making what happens at school really relevant and engaging for students too. That it's not just about ideas about kids coming from different kinds of backgrounds or not having parental support. So I don't know. Not to keep going on, but I don't want to suggest that any of these countries have everything figured out either. Equity issues is a huge issue on the agenda everywhere, particularly post-pandemic, and yeah.
School start times.
Okay, thank you very much.
Sure.
I had a question as well. I'm curious in some of these other countries how the status of a teacher is, comparatively. In the US, in a lot of places and a lot of times, teacher is not a high status position.
Mm-hmm.
I think that's a disadvantage to the schools.
Yeah. I think I'd say sort of looking broadly across a lot of the high performing countries, the two things that jump out immediately are things around the sort of alignment and systemic nature of policy in schools, but also the idea about the role of a teacher being different in terms of its status and sort of how the profession is organized, I would say. I do think sort of historically the role of a teacher has been, it's a high status profession in many of these systems. Getting into teacher preparation, I was going to talk a little bit about the teacher stuff, but can jump to it now. Teacher preparation is a competitive program to get into in many countries. The pay is, not always incredible, like the highest pay, but often pay of teachers is a well-paid job in the society and sort of benchmark to other professions with similar type of education requirements. I think that also needs to be understood in the context of in many countries outside the US, the income distribution is narrower to begin with. So you don't have quite the level of, billionaire doctors and other kinds of professions. A lot of professions are more in a common range, but I do think you certainly when you go to just talk over history of teachers in a lot of the countries. A lot of the systems that perform really well are systems that have, rebuilt their education systems after being occupied or war or away from Russia or something like that. And teachers and sort of education has been part of a sort of the idea of nation building, and teachers have taken on sort of a role in that way that's somewhat different than the way that they're perceived in the US. So I think that's the case. I do think over time that has changed in some of these countries, and some countries that have traditionally not had teacher shortage issues at all because it was such a high status profession are struggling with some of the issues that we are struggling with in the US. But I think overall, when you look at it, that it is sort of a different kind of position. Some of the stuff that I can mention a little bit later, but also that we've looked into in some of our other work is the way that the teaching profession operates. I mean, some of the stuff that just sort of jumps out at you when you talk with teachers in other countries is you ask them what are teaching hours at a what are the hours for the classroom, and they don't even know what you're talking about because nobody's holding them to be in a building at 8 a.m. and have to stay till 4 p.m. Like they're there when they need to teach, and a lot of their time is spent learning and working with other teachers and not spending all of their time in front of a classroom. And it's organized in a way that more resembles, at least the way that we would talk about it, more resembles other high status professions than often the way that we organize it in the US with, you have exactly 22 minutes of planning time on this day and those kinds of things. The schedules are much more flexible and reflect a different kind of way of working.
I just had a question about how they balance literacy. For example, in our district, they spend 120 minutes a day on reading and 45 minutes on math. And is it more, I don't know how to say it, inclusive or comprehensive, or, how do they balance that?
Right. For this, I haven't looked specifically at that, but one thing that's interesting, I think, that's always sort of jumped out at me is you don't see either. I mean, one of the things that we're going to talk about with math was the sort of extended blocks of time for literacy or math that you see in the US. But I do think it's notable in many of these systems. Students are required to learn more than one language. So while they may not have more time spending learning Estonian, they are learning English, starting in elementary school as well, and often a third language. So I think if you added all of that up, they may actually be spending quite a bit of time on languages and literacy and reading that are not necessarily sort of in the mother tongue or the national language context. But just to sort of jump from that to the sort of thinking about instructional time, one of the things that we thought was interesting is that we weren't seeing, I mean, it sounds like you don't have it where you are, but we weren't seeing huge time use blocks, especially in elementary school for mathematics, the way that we are often seeing it in the US now. And not only not huge blocks of extended time, but what was interesting, particularly interesting is the small amount of time that's spent on it. In many of the countries, as I said, the national curriculum specifies time allocations by subject area. And, they do it in different ways and with different levels of flexibility. But quite often, sort of, this would come out to something more like 30 or 40 minutes of math a day, and often 30 minutes at an elementary level. Estonia is one example where they'll specify, I think it's 10 45-minute math lessons each week across grades 1 through 3. And schools can divide it up however they want, but that comes out to something more like 30 minutes a day in mathematics, and they might not do it every day. But it's sort of interesting to think about that there wasn't a clear correlation between time and performance in the way that often in the US, we just think that more time is better. Which it may be in some cases, but it seems to raise some questions about what you do. What are you actually doing with the time? The other thing, besides not spending sort of extended time on mathematics, is just in general, lesson periods are quite short. And there's a lot of breaks in the school day. And it's interesting to sort of step back and think about that from the perspective of, how kids learn and their developmental stages. And in many countries, there's actual requirements in the curriculum to take 10 to 15-minute breaks between lessons, even at older grade levels. And those are breaks both for teachers and students, and additional sort of recess time during the school day and things like that are, again, interesting to think about. I mean, the Asian countries in particular have really, often have 35-minute lesson periods where they really sort of have a really well-designed short focused lesson that they tend to have, and then a period of time for kids to get up and run around and be active, which is interesting. At the high school level, we also saw a number of systems that for mathematics and for other courses as well, sort of chunk high school courses into small courses, and in some ways it's more college-like, where students might take 4 math courses over a year, sort of short courses that are, I think Finland has 35-hour courses, and they're assessed at the end of the course, and they sort of are broken up into different topics and areas of math that some are required and some are optional. So it's just a different approach to thinking about using time. Again, we'll pause, or I will move on to some of the teacher stuff, some of which we've talked about a little bit, but as we talked about a few minutes ago, one of the things that's quite notable is that math teachers and other teachers are quite well prepared in content in teacher preparation. This sort of, as I said, getting into teacher preparation is a competitive program to get into in many countries, and the entry requirements look at academic and content expertise, but also often are requiring students to have had experience working with students. They look at dispositions of students, and they look at research skills. So there's a much broader sort of way of thinking about who is a good candidate for teaching. One of the things that I know has been a big conversation in the U.S. too is elementary school teachers are often have a math focus or math expertise, and that's been the case internationally for many years, but it seems to be increasing. There's a number of countries that are moving in that direction, that previously had a more general preparation for elementary school teachers. But even in countries where teachers had general preparation for elementary school, there's often a requirement to have an area of expertise or 2 areas of expertise. Teachers also, and we talked about this a little bit before, have high quality materials to use. So their time is spent on adapting the materials for their classroom. And significant, and this is something that, has been a discussion in the US too, significant time for professional learning and collaboration during the week and during the school day. Where their teaching responsibilities in many of the countries are really more like half of their time, and half of their time would be spent in planning, working with students, collaborating with other teachers, research projects and studies at the school, focused on problems of practice at the school, and significant mentoring and coaching that is sort of built in to the system. So again, I think some of that stuff are things that are being discussed and things that folks are trying to work on a bit more in the US than previously, but it's still sort of a significant difference in how teaching as a profession is organized in many countries. And that's an overview, and I don't know if there's other big issues, things that would be interesting to learn more about. I mean, I'd be interested just to hear too about things that would be interesting for us to do more work on that would be useful for folks working on these issues too.
Jackie, this is Kim again, and I'm just curious about what you've seen relative to the amount of money spent on standardized testing in other countries relative to what we see in the United States.
Yeah. It's hard to make a comparison. I think at least my understanding of it, and I haven't seen recent sort of really looking at the testing, the cost pieces, but my understanding of a lot of it is that in general, and it's changing because of technology, which is changing, sort of online testing sort of changes the calculations of how you're doing this and how you test even. But in general, we've often seen that the tests that are given, that there's less tests that are given, but they're higher in some ways quality tests and perhaps even more expensive types of tests, because they are often tests that require problem solving and essay writing and they tend to be not multiple choice types of tests, which we have tended to use in the US more because they're inexpensive and because we give so many more tests than are given in other countries. The other thing that is different, has tended to be different in other countries, is that sometimes these tests are teachers are involved in scoring of the tests, or there's often processes for moderating the scoring that is done by teachers of the tests, which is something that we don't tend to do in the US because of concerns around bias and other kinds of things. There's a little bit less of a legal framework and approach to sort of testing in that way. But it's something we looked into in a lot of detail many years ago, and I don't think we've done an update on it. And my guess is that some of this is changing a bit with the use of technology in testing. So.
And Jackie, I know we need to get going because we have some more on our agenda. Chris did have a question about what school start times look like in other countries and how that compares to the US. So the actual school day.
I think it varies in countries. There's a number of countries where the school day is very different. The amount of time in the school day is very different for younger kids than older kids. And particularly in some of the Scandinavian countries, school days start later and end earlier, particularly for kids at, in primary school. Many of the other countries, it starts at 8 or 7 or 8 in the morning, like it does here. But I think there's a variety of school days. But what's interesting is the variety, and it's also the often sort of intentionality of different schedules for different ages and developmental levels.
Nan, is there time for another question, or should I follow up with Jackie directly?
Let's go ahead and stop for now. And Jackie, we will be sharing your PowerPoint and we'll be sharing this presentation online.
Sure.
And if it's all right that I share with the coalition your email address, if anybody has any questions.
Sure.
And perhaps another time you can come and share some other studies with us. If you have anything on science, we would love to hear that. And I know you have information on more pathways in high school. So thank you. Thank you for sharing all of your information with us. It's been very informative to hear what others are doing, and in particular, as Ohio is looking to see what we can do better. It's interesting to hear all of this. So thank you very much. We appreciate your coming to us this morning.
Thank you. And I'm sorry we ran over a little bit. I just realized what time it was. Anyway, okay, good luck. Thank you so much.
Thank you. It was wonderful. It was wonderful.
It was fabulous.